This next demonstration on sieving is going to involve using a combined aggregate material. And just to give you a visual definition, shall we say, of a combined aggregate material, this particular bucket is not the material we're testing, but it is a combined aggregate that has a significant amount of larger plus more material, as well as a significant amount of fines, which presents its own problem depending on the type of sieves that we're using. So I'm working over here at the lab. We've already done all the preliminary work. I have a 3/4 inch minus combined aggregate material in my pan that has been reduced down with a mechanical riffle chute splitter, dried on the stove to a constant dry weight, which is what we're determining now with the pan sitting on the scale. And we have 2,092.9 grams is the original dry weight of this sample. Now with this material, we do need to determine the total amount passing the 200, which then again would mean washing this sample in the pan over a number 200 sieve as demonstrated earlier with the sand sample. We have to wash this material and determine how much washing loss we have. Once we have that established, again, we would weigh the material on the scale after it's dried to a constant dry weight, and we ended up with a dry weight washed, the sieve analysis portion of the worksheet, 2,065.5 grams. From there we can establish our washing loss, the amount of minus 200 that we washed through the 200, simply subtracting the original, subtracting the washed weight, and in this case we ended up with 27.4 grams that was washed out of the sample. Just as a heads up, when you're dealing with this kind of material, the washing process over the 200 is going to be a little more involved because of the excess amount of fines in it compared to concrete sand or coarse aggregate concrete. All right, now we've got the sample again, original dry, then washed, the dry weight washed. It is now time to do the sieving operation. With a combined aggregate material, we have a couple of options depending on the equipment that you have. If we have a full nest of 12-inch sieves, then we can just dump that material, the entire sample, usually into the nest of 12-inch sieves, sieve to completion, clean out the sieves, and weigh up and record the material. Some folks do not have the availability of a full nest of 12-inch sieves, which is what we're presenting in this video, is if we have box sieves and 8-inch diameter sieves, with this amount of fines, we have to be careful to not overload our 8-inch diameter sieves. In fact, there are specification requirements that on the 8-inch diameter sieves, we have no more than 200 grams retained after sieving on any one 8-inch diameter sieve. That is a specification that's stipulated in the IM 302, and when you look at your bottom part of your sieve analysis worksheet, you'll see that information is also included on the bottom part of your sieve analysis worksheet. So again, that's what we need to avoid. So we would take this sample now and run it through our box sieves, which we're not physically going to do because we've already accomplished that. You'd run it through your box sieve, starting with the top size screen required. In this case, we had to make sure 100% passed the 3/4, and then we screen it over the half, the 3/8, and the box 4. We stop, we're going to do the coarse aggregate portion of the sample first. So that's why we stop with the box 4. Weighing and recording those weights, which we have accomplished. I have those weights ready to go. Go through these weights. On the number 4 sieve, I'm working bottom to top in the second column of your sieve analysis worksheet, and we ended up with 400.8 grams of +4 material. Again, working in the second column, working my way up from the 4 screen up to the 1/2 inch. The 3/8, we have 190.5 grams. And the +1/2 inch, I have these tagged so I know which is which. We have 80.2 grams. 80.2 grams. Now, IM 302 tells us to reduce our total -4, which we have to establish. We box sieve the material over a number 4 box sieve, and then we weigh and record the total -4 on your worksheet towards the right. In this case, we ended up with 1,394 grams of total -4, which would completely overload if we were using 8-inch diameter sieves. IM 302 tells us for procedure B to take that total -4 and reduce it down appropriately over at least a 1-inch, or if you happen to have a sand splitter, reduce that sample down, and we need to have at least 500 grams. We had to follow our reducing protocol to reduce complete increments. So we reduced this one in half and ended up with 696 grams of reduced -4. Then we can put it into our 8-inch diameter sieves. On the 8 screen on down, we do not need to rescreen it over a number 4 sieve because we did that with the box sieves. So we screen the sample down, again, approximately 10 minutes or so in the electric shaker. Clean out the sieves, similar to what we did with the sand sample, as was demonstrated, cleaning out the sieves, making sure we're sieved to completion, and we end up with individual increments of the total -4 that has been reduced down and then sieved. And we have our weights in the pans, and I will go through those. Myself back to organized here. I again am starting with the bottom pan weight, working my way up. This is recorded in the first column of your worksheet. So in our pan we have 2.1 grams. That's material that again passed this 200 sieve after dry sieving. We have our washing loss next. Excuse me, we don't have washing loss in this column. We have our +200, 13.2 grams. We have our +100. 60.6 grams. And then we just work our way up through the 8 screen. We have our +50, 140.1 grams. Our +30, 124 grams. Our +16, 157.2 grams. And last but not least, our +8 material, which ended up being 201.5 grams. With that number, 201.5, I would point out that actually does exceed the required maximum amount of 200, but the appropriate operation would be then to, again, making sure you're sieved to completion, and that is close enough that that would not throw the results off.